piecewise functions. So in this first example, I identified on the graph what the vertex is, and I chose one good intersection point. And you can see there's many good intersection points, and here's a great one to use actually. But I chose one good intersection point and I identified it on the graph. Now to write a piecewise function, we need to start by coming up with an equation of this parabola. So because we know the vertex and we know one other point, we're going to go back to what we learned earlier in this unit. Y equals a times the quantity x minus some number and plus or minus some number. And remember, this will be our vertex. So for this problem, I have y equals a. It's going to be opposite of the inside, so here's your x value for the vertex. X subtract a negative 5, quantity squared, and then minus 8. Now why is it minus 8 when there's a plus sign? Whatever your y value is for the vertex goes in back. You don't change the y value. I am going to rewrite this seeing that two negatives make a positive. And now I need to figure out what is the a value. And I can determine the a value by choosing one other good intersection point. In this case, I'm going to use -4, -5, but I have other points I could have used. This will be substituted in for x and -5 in for y. And now I'm going to solve for a. I didn't leave myself enough room. Okay, so I'm going to start by adding 8 to the opposite side. So 8 minus 5, I'm going to come over here, 8 minus 5 is 3, and 1 squared is 1. And when I divide both sides by 1, I get a equals 3. So one equation here is y equals, again, a is 3. Let's go back up to this point right here. Y equals not a, but 3x plus 5 quantity squared minus 8. Now I need to come up with an equation for this line. Now notice I can see exactly what the y-intercept is. I can see exactly what it is. And I need to go from left to right, always left to right, to determine the slope. So from left to right, I'm going up 2, right 1, up 2, right 1, up 2, right 1. Left to right, so up 2, right 1, up 2, right 1. So for this particular line, y equals a slope of 2 over 1x, and it has a y-intercept of 11. It's not necessary to put a 1 underneath, but I put it there just so you can see directions of how I created this slope. Okay, the last thing is we need to say, when do we apply this function on the graph, and when do we apply this function on the graph? And the key is, look at where these two functions start and stop. Also look at that we have an open circle here, and we have a closed circle on the parabola. So both of them are going to be 1, 2, 3, -3. So -3 is the key number. And this parabola is going to occur to the left of -3. It's going to occur to the left -3. Notice again that it is closed. So this parabola occurs where values are less than or equal to -3. And this linear line occurs where x values are greater than -3. It's open circle, so I only use the symbol greater than. Notice, think of this as an arrow. An arrow for this part is going to go to the right, and that's correct, with the linear line to the right of -3. And think of this as an arrow. And the arrow says to the left of -3 will be the parabola.